Hey everyone, in the last video we created these different biomes here by using this Colormap, and we want to use it to implement a temperature. Here is our data table that we already prepared in the last time. We have the mountain desert temperated integer zone, and we have already implemented here this one, the temperature curve, but we did not create the curves at the moment, and we want to do this now. So we will go here now to the curve and add another curve, which is just a simple float curve. I will go with maybe a few values, so start the key here by 0, and maybe just at midnight we have a temperature around 17 degrees, which is now at 24. Which should be the same as at 0, of course. Add a key maybe at 16, and let's have a day which with a temperature of maybe 28 degrees, and maybe the lowest temperature will be around 5 AM. So let's add another key. It's 5 AM, and that will drop maybe to 14 degrees. So let's go with that, and we will flatten the curve here and do the same here, because this is our maximum point. And I will create the same curve also for the different other zones. Just apply this one, temperature curve temperated zone, here to this one. Okay, so I created the different curves and we can apply it here. So we can close this and then go to the get single temperature function. And what I need is, of course, because we have a day, I need the in-game time. And yeah, of course I need the information of the biome struct that we created the last time, and there we got the temperature curve out of it. If we want to blend the temperature, and then for the blending we need the current temperature, of course, and we need maybe the day length. This could be important. Just if you vary the day length a lot, then the interpolation speed has to change also. So we can use this, and so okay, now if we want to blend, we have to do different more stuff, and if we do not want to blend it, we can just go to the biome, break the struct, go to the temperature curve and get the float value out of it, the float value, and then we need the in-game time. And yeah, I think it's fine enough just to work with the hours and the minutes. We can ignore the seconds. We don't need the precision, so just the hour. And yeah, we have to convert this to the float, and then use the minute value, divide it, just convert it to the float, and then divide it by 60. Because we have 60 minutes in an hour, and this float value is depending on the hour. So we can, so now we have a float value here. We can just add this both values and choose this one, and then just export it as an output. Here we have the temperature. Just for the false, it's simply the temperature. And if we want to blend it in, we can simply use the interpolation interpolation function. And yeah, our current temperature is here, this one. And our goal or our target temperature is this one. And the delta time is Watt delta seconds, this one. And the interpolation speed, as I said, maybe vary a lot of the day length. So you can try different values, but what I figured out is maybe that we have a good value with divided float 500 divided by the day length, and just to make it not too quick, you can clamp the value, or too slow, and type in that this should be between 5 and 500. So this is fine. And yeah, let's return this value. And we can try it with the temperature now. So we has this already implemented into our third-person blueprint to the character. We can go back here and open that, and this is the function we wrote here to get out of the map the pixel and the biome and the information about the biome, but we don't want this. Now we want the get temperature and get single biome temperature. So this one. And what we need is for that is the biome, of course, and do not want to blend it in the moment at the game time. And this is something I already prepared. You can see it in another video. You can ask this from the game state. And use the in-game time here. Just plug it in. And the same with the day length. No, we do not want to set it. Just want to get it. The day length and the current temperature, of course, is something from the last tick or from the last calculation. So we will store the value here as a temperature, and we do not use the blending, so it doesn't matter, but I will plug it in just in the case we want to use it maybe later. So, and that's all. So we can append it. And we have the biome name here and the temperature here. So let's try it out. So now we are here in the taiga zone. We have a temperature of 14 degrees. And maybe let's go to the desert. And we see it's 28 degrees. But as you already mentioned, it's completely changed. So here are 14 degrees, and if I'm going to the desert zone, then it's raised up directly. In our map, we will not use only the position, we will use a circle or a square around just to weight the different temperatures and use than the middle of both. And if I'm more inside of the desert zone, then the influence of the temperated zone will drop, and sometime I will just have the impact of the desert zone. So, and that's what we want to achieve, and for that I will write another function which is transition biomes. Transition biome. So, and we will use this function also for all the stuff we had it inside of our third person character. So we will just use all of this stuff here. And I will call here simply the function get transition biome. But in the moment we have no input and output for that. We will change this now. So all the stuff all we need is in the one hand, of course, maybe this map what we are using can be an input. So this is the texture. And what we also need is the actor. So we can use this at the player position. The radius, and this is it's the blending radius maybe. So how much of the pixels around the current position should be taken into account. Yeah, so we will create this as a local variable, this one also, and yeah, just refresh this node. We can maybe change or delete the last part. We will implement this later. In the moment, just we want to get the different biomes, and maybe I can make this a pure call here just to make it easier. So, and now I want to maybe I save this as a local variable with the landing. And yeah, simply just go through all of the different positions. So what we do is we will implement two different for loops. One for loop to change the Y position and one for loop to change the X position. So I will go with the Y position, and I will start by subtract the blending, and I will go until adding the blending, and we have the blending here, and plug it in. And yeah, let's do the same here on the second loop, but then just for the X position. And what we need then is we need the get pixel, but of course not with the total X and Y position. We just need the index of that, and we have the X position here and we have the Y position here. And yeah, we find another biome, we want to store it inside of a new variable, but we do not want to have an index of all the biomes in the end. Well, we could use it, but we just want to count how many of the biomes are there. And yeah, let's add in create another variable, which is the log biome. The select biomes, and it's of course the biome structure, and it's in an array, and we will add unique elements just to this one here. And yeah, we want to add this, and we will have another variable which will count all of these numbers, and this is our counter. This is just a simple int, and it should have the same length of the biome. We could use a struct for that to make it more consistent, but in the moment I will stick with 2 arrays. That's fine enough. So, and now we have to see if we add a new element here to the biome struct, or if we add in biome which already exists. So if this is equal to -1, that would mean that it already exists and we did not add it in another one. And if we add another value, we will get the index here out of it. But that would mean just we have to add here, and of course another one biome was added, so we can use this one, and if not, then we will adjust. Sorry. And if this is -1, that would mean that this biome was already inside of our structure. So we will use this, and we want to find the index of this biome here. And then we will use this index to get the count value out of this. And we want to add another value. So we want to increment this and use this one to set an array value of the count. Set array element, and the index is this index what we found here, and the item is this one. And just to make sure that there is no error. And yeah, now we got these array of biomes and the array of counts, and this is our output. This is what we want to deliver. So we have one is the biome. So these are our biomes. The struct is an array, and we have the counts. This is also an array. And yeah, we will have this output here when we finished all of the for loops. This one. This one. Okay, now we got an array with all the biomes and the counts. So we could take a look in that, but maybe we can do this later. And now we want to have a weighted temperature. So we will create another function, and we want to get the weighted temperature. And what we have as an input is of course our biome struct here, and of course our counts. So we will create different inputs. So we will have our biome structs that we created, biomes and counts. And what we already also need is, as we already used for the single biome temperature, we will use this. Then we'll need the in-game time, so the date time, And yeah, and then of course we would also need the other factors like the current temperature and the day length. What we have here is an input, or if we want to blend it. In the moment, I just stick with that. I do not want to blend in, or just use the blending function, so we can stick with that. And the first important thing is I need some weighting factors. So I have here a count, which means in the end it has maybe 5 by 5, it's 225 biomes. Oh no, we have plus 5 and minus 5, so we have 11 times 11, so we have by these counts it means we have now a blending radius of around maybe if we pick 5, so we have 5 in the north, 5 to the south, east and west, so that would mean we have 11 times 11 fields, which taken into account it's 121, and we want to normalize this value and get a factor out of it. So just use another function, it's get weighted factors. Just make it private, and what we have as an input is just the counts, and what we have in an output is then of course an array with the weighted factors. This one. So it's quite simple. We just need a variable where we have to count all of the numbers, so the total count. We could also use it as an input. We know that we have an blending radius of 5, so we can put this in and then calculate it, and this could save us more calculation time. But if you do not want to have this, you can recalculate it, and it's just a simple for loop. And yeah, just make sure that the total count is starting by 0, and then you will just sum up all of these elements. I don't know if this is, no, it's not possible to sum, so we have to take this way, calculate the total count and sum up all of the elements here. So that's already for that. And then for all of the elements we have here, so the same, but we have to do it in a row because now we will calculate the weighted factors. Of course, we already need the completed calculated total count, so just we have to calculate the total counts in the first round, and after that we will calculate the weighted factors, and these are our local weighting factors. And these are the float values, and should be an array, of course, and we add another value here, and this is this one, and we want to divide this. Is it possible to normalize now? Okay, and then we want to return here all of our weighted factors. This one, that's it. So we can go back to the weighted temperature, and first of all, oh, it just did not rename it in game time. This one. So we have the weighted factors, this one, And of course we will first store it in a local variable. So, and then we will go over all of the biomes we have here for each loop. And for all of the biomes, we will calculate the single biome temperature. And I will add another log temperature array variable here. Get this and add another one. This one. And we have the biome and the in-game time. And as I said, I will not use the blending in the moment. We just want to blend over the distance, but not over the time itself. So we can ignore these values here. And yeah, if we filled up our array with all for the different biomes we had, with the different amounts, we can go now for each of the different temperature we stored here. Or we can use also the different weighted factor. It has to be the same, so it's doesn't matter. But we will go over this temperature array that we filled here, and here are our weighted factors. And now we want to recalculate the temperature, which is another variable, so it's the log temperature, but it's just a single value, not an array. And we will get the element here, this one, and just multiply it with the temperature. So we have now a temperature, maybe if the half of our temperature, of our biomes at the desert, then we have here a factor of 0.5 times the temperature of the desert plus 0.5, maybe if we have a temperated zone, times the temperature of the temperated zone. So we add this and store it then here in our variable, and then we have our weighted factor, and we can return just the temperature. This is just a single value. So this is the log temperature. We could also use some blending here, but in the moment we don't need it. It's just another interpolation. So it's easy to do if you want. So and then we can use this function here. So it's our map that we have, and this is displayer. In the blending radius, as I said, maybe around 5 pixels. So the 5 pixels north, south, west, east. And then we want to get the weighted temperature out of it, and the game time we get from the game state, and we want to print out the temperature itself. And yeah, let's see if this works. We see here now we are in the temperated zone around 16 degrees, and now we will go inside of the desert, and you see if I stop moving, we can use the output out of it, this one, and print it out. Let's try it out. So we see now we are completely in the desert, and if I go into the temperated zone, now I'm completely in the temperated zone. I can go into the mountain. Now you see I have a bit of influence of the mountain and a bit of influence of the desert zone. And yeah, let's go closer here. Now the taiga zone into the mountain zone here. And now we are completely in the mountain, in the cold mountain, so we have just 4 degrees, and now run into the taiga, and it's a bit warm, and then we go into the temperated zone here, get more warm, and now go to the desert, and it's even more hot. So you see, it really worked. And now you can take this and do whatever you want, showing in the HUD or using for different more calculation, and that's the same for the different other values. Thank you, and see you in the next video. Bye.